So here we're on part 2 of the exam, and part 2 is talking about this net flow rate here, about this network of pipes where we have node 1, node 2, node 3, and what is kind of node 0, node 1, node 2, and this node 3, which is kind of the environment, where we have info for each of the pipes, and we need to figure out. Part 2 is talking about calculating the flow rates and figuring out the flow rates in the middle of each of these pipes. So we need to edit this as our template and go from there. So we need to figure out what's good to keep and what's not good to keep. What's not good to keep are these head 1s, head 2s, and Z1, Z2s. These are not quite up to snuff about what we need because there's so much more info here. Just writing these variables here won't cut it, so we gotta get rid of these. We also have to include this thing called K now, where K is where we can alter frictional heating, where we need to change the value of frictional heating drastically, because if there's like a sudden change in radius of or diameter of the pipe, or it goes outside, or between each node, or there's like a right angle, those are values of K. So we need to change this to be, first we need to add this value of K in, and then we need to return something different, and that something different is where we still have the sign of Q times, here's the K, plus 4 times F, which is the Reynolds number, still got that, ED times L divided by D times V squared divided by 2 divided by G. So we got all this, and here we factor in K, so now we can use this K to get a more accurate approximation of the pipes. So now we need to include K into this now, and K is just that, so okay. And then we also need to include K here. So now that we have all this, we're now ready to start coding new stuff. So now we're ready to start coding for all of the new pipes and get all the flow rates. So where we need to start is, whereas before we included all of the values of pipes up here, we need to do that a bit more systematically and a bit more organized. So we can do that in an array. We can do that pipes equals mp.array, where we have the array is going to have columns of, the first column is going to be everywhere where it's going to be like, where each row is going to be info about one pipe, and each column is going to be one aspect of all of the pipes. So the first column is going to be the 2. So in this case, it would be 0 because it goes from 0 to 1, or from 1 to 2 will be 1, or from 0 to 2 will be 0. Or from 1 to the environment, it would be 1, and like that. The next would be the 2, where it goes from, if it was from 0 to 1, it would be 2, so it would be 1. Next thing we would have the array do is be length. The next one will be length, followed by K value, and followed by the D, or the diameter. So, like I said, for the first column, it'll be 0, 1, 20, length of 20, K value of 1, and then a diameter of 0.1. So I'm going to type this in for the rest of the pipes now and come back to you. So we're back, and I have all of the pipe data entered in. As you can see, we have 001122, which matches from goes to the 0 has 2 pipes going out of it, the 1 has 2, and the 2 only has 1, and matches like that. So for the rest of the data, we're going to need to talk about the z-values. So the z-values here, we assume that our guess here is going to be 15, and the rest of it here is going to be 0 otherwise because it's stated or it's the environment. So what we need to do here is np.array, where we're going to have 15 as the first element, and then 0, and then 0, and 0. Cool. And the next thing we need to do is we need to include things about the pipe and the ratio of E over D, where E over D here is 0.001 for all the pipes. So how do we do that? Well, I could just type it out, but first thing we need to do is figure out, we want to have an array the size of all of the pipes. So I could just say it's an array of a size 5, but we want to have the number of pipes. So how we do that is we just do n, and we're going to call this n pipes, the number of pipes, and that equals pipes dot shape. This is the shape of the array, and this is going to be the 0 column. And that gets you like the number of rows in the first column, or the 0th column. And then using that, we can have an array just for the pipes of ED. So that would be pipe, we're going to call this ED, and that's going to be np.full, full array. It's going to be size n pipes, and it's going to have values of 1 e to the negative 3. Oops, only one bracket there. Cool. Now that we have that, we can start taking some information out of this also. First thing we're going to do is we're going to have a column vector, or basically column vector, of all of the 2 nodes, and then one for all the column, and one of all the from, one of all of the 2, one of all of the lengths, the diameters, and the k values. So what that is going to look like is from node equals pipes, and since we want the entire column, we're going to have a colon there, and it's a 0 because Python starts at 0. But the reason we want this, at least in this case for the 2 and the from, is we can index these later. So we need to write these as integers, so as type np.int32. And I'm going to repeat these for the rest of the nodes and all the columns. So we're back. I included everything. I included all of the I included one column vector for each of the columns here that we need, and we don't have the last 3 as type of integers because these aren't being referenced as indices from now on. So don't need that. Next thing we need to do is we need to mark which nodes are our external nodes and which ones are So we can do that by saying external P indices, external P indices, DICI indices, and that's equaling to 0, 3, which means that this is just the 0 and third nodes are externals, and external P, this is just going to be an array, so np.array of zeros. And this is because here it says pressure here is 0, and the environment's going to be 0 anyway. So now we have all this taken care of. Last thing we want to do, housekeeping wise, is we want to do the number of nodes we have itself. So that's just nodes, number of nodes, equaling, we want the maximum value of this column here. So what that means is we want np.max pipes. We want the first column, so the 0th column, and we want it ranging from element 0 to element 2. And then we want it as a type, we want it as a, we want this as a integer again because we want to reference this in the future. So np.int32, and then we want to add +1 because once again Python starts indexing at 0. So we talked about the external nodes. Now we need to talk about the internal nodes. And the way we do that is we take the set of all nodes and we subtract away the set of external nodes. And once we do that, we have the set of internal nodes. So we need to define first all of the internal stuff. So internal indices, and we're going to do this in a list. So list set np dot arrange n nodes as type np dot type, or sorry, no, as type np dot int 32. So this treats it as a integer and not just floating points, which is good because we need to do set subtraction to it, and we subtract away the set of external nodes. So external P indices. And see if I made any mistakes there. Of course I did. Invalid syntax. What did I do wrong? I figure out what I did wrong and come back to this. Internal NDIC indices. Cool, so we're back. I just mistyped indices and had an extra R in arrange. So, love that for typos. Anyway, now that we have This is a set of all internal indices. We also want the length of that, so we're going to do n, the number of internal indices, and that's just the length of internal indices. Wow. Cool. Now we can start. Now we're well on our way to start calculating the flows and the net flows and the heads and everything like that. So what we need to do is we need to make a bunch of general arrays full of zeros so we can start putting things into them. So we're going to put flows equals np dot array or np dot zeros. We're going to make a matrix of zeros, and it's going to be size n pipes. Yeah, that's the way you do it. So, and then we're going to do the same thing for net q, and we're going to do the same thing for everything that all the properties these nodes could have. So the flows, the net flows in and out. I'm going to make sure the pressure and the heads. So we're going to copy that for all of these. I'll be right back. Now we are at all of the. Now have arrays for the flow, the net flow, the pressure, and the heads at all of the nodes. Cool. Now the last thing we need to do is have a matrix for the no, we're done now. That's it. So now we are just about ready to start calculating things. First things first, though, we need to start importing. We need to start filling these. We start at least filling in some of these matrices. So first things first, we need to fill in the pressure array, and it's going to be at external P indices, and we're going to fill that in with values of external P, where external P, remember we set up here was just 0, 0, because those are the pressures at external. Next thing we're going to do is we're going to talk about the average. Now we do some guessing about the head. So the average head will be, we're going to call this external guess, average external guess, which is equal to, and we're going to call this the mean of all of the heads on the outside. So the heads at 3 and the heads at 0. And that means we're going to np.mean to take the mean, and that's going to be external P divided by rho divided by G, so the head, plus Z, but only at external P indices. Love the autofill feature. So that's the average external guess, at least. We can, obviously we don't know the head now, but we can guess and fix it later. Now what we need to do is for the internal, so the internal nodes, and how we do that is we just right now we're just going to call it the same thing as the external heads, because why not? We don't really have anything else. We don't really have anything better to use. So external guess, or internal head guess, which is, we're gonna make a matrix full of. It's going to be an internal. It's going to be of size and internal indices, and it's going to be of value AV external AVG external guess. Now we just need to, next thing we need to do is to take the internal pressure, and we need to guess that. So how we do that is we're gonna call it the internal head guess. The head and subtract off z times rho g. So the next thing we're going to do is we're going to take the, now we're going to have an internal guessing for the pressure, and we just have head equaling pressure over rho g plus z, and we're going to solve for p there and subtract everything away. So we're going to have internal p guess, internal p guess, and we're going to call that, the internal head guess, minus z at the internal indices times rho times g. Cool. And finally, we're going to talk about the pressure for, and now that we have that, we can just fill in the pressure matrix here, like we did for the external. And how we do that is we just, we're going to fill in the pressure at internal indices, and we're going to call that internal P guess. Internal P guess. Whoops. Cool. Now we are ready to start calculating things.